Okay, so we are now in section 9.6, where we get to translate and classify conic sections. Up to this point, each section dealt with one of the four conic sections, whether it was parabola, circle, ellipse, or hyperbola. In this section, it deals with all four conic sections. And not only is it dealt with all four of them, it deals with the translated positioning of those conic sections on the graph. The sections prior to that, we were dealing with um, graphs that had either, if it was like a parabola, our vertex was at 0, comma 0, or if we were dealing with the circles, ellipses, or hyperbolas, our center point of those graphs were at the origin 0, comma 0. Today, where our center points as our vertexes are shifted um, in our horizontal and vertical translations through H and K. We've seen H and K before in other applications, so that's nothing new to that. But what does change is uh, the points on the different conic sections. Due to the length of this lesson, it's going to be broken up into two sections. So this is part one, and then I'll have part two to follow. So here we're going to start with the standard equation for a translated parabola. So translated parabola, again, we had two equations. The first one is x minus h quantity squared equals 4p times quantity y minus k. So that is when our graph is opening either upward or downward, depending on if it's positive or negative. And then the second one is y minus k quantity squared equals 4p times quantity x minus h. This one deals with the parabola either opens to the right like this or to the left. Okay, so there is a general switch when it comes to the coordinates for um, these points. So if we look at the vertex here in our first equation, we remember that the vertex, when it was our standard, just x squared equals 4py. Without the translation, it was 0, comma 0. And so now this one here is dictated by whatever h and k are. So h comma k is our position of our vertex, whatever that may be for any specific equation. Our focus, if you remember for this one, was at 0, comma p. So here we're going to, so if it was 0, comma p, so that means it'll be switched to h, and then it's going to be k plus p will be our location of our focus. Our directrix here is going to be y equals, and then before it was a negative p, well, this one's just going to be, what would it be, k minus p. The axis is symmetry. Beforehand, it was at x equals 0. Now here, this one's going to be x equals h, whatever that the axis of symmetry is. And then dealing with our second equation, our vertex is going to be at value, again, h comma k, whatever that translation is. And then our focus, when we were dealing with our standard, the one without the, when our when our vertex was at 0, comma 0, was that y squared equals 4px. That one was at 0, comma 0. This one's at going to be, it would be what? H plus p, comma k. The directrix is going to be at x equals h minus p, and the axis of symmetry is going to be y equals k. All right. And so if you were looking at these on the graph, so say I positioned it here, it would look something like this, something like this. So if this was at 1, 2, 3, 4, so, and then 1, 2, 3, so the vertex is at 4, comma 3. So in this example here would be x minus 4 quantity squared equals 4p times y minus 3. You know, that's where we get the directrix here. The same thing goes here. It just means that the positioning of this, but p would be a negative number. Same thing goes here. If p is positive, like say if my vertex would be here, it'd be a position to the right. And then if it was negative, it'd be positioned to the left, or opening from the left. Okay. The standard equation for a circle is a little easier to see from the equation, because not a whole lot has changed, because we had x squared plus y squared equals r squared, and now we include h and k for our shift as our center point. So our center of our circle is always going to be the coordinates of h comma k, and then our radius is still denoted as r. So if we have a center point here and our circle, we'll say that it's at 1, 2, 3, 4. Say our radius here is 4, so r equals 4, and our center point is at 1, 2, 3, 4. So this is at negative 4, comma 1, 2, 3, 4, positive 4. So if I were to write this out as an equation, it would be x plus 4 quantity squared plus y minus 4 quantity squared equals 16. Okay. The next one's the ellipse, and if you look here on the bottom, none of this here has changed. The value for the major axis is still 2a. The value for the minor axis is still 2 times b. B will always be the larger value when we're dealing with ellipses, and the larger value dictates whether it's the hot dog or hamburger ellipse that we talk about. The first one is the hamburger one, because it's kind of wider like a hamburger, and then this one's the hot dog one. It's kind of longer like a hot dog. So the major axis here, this is what it's considered the horizontal, and the vertex before it was dictated by the value of a, so it's going to be a, but then we have to add whatever h is going to be, comma k, and then the other diversity would be what? Negative a plus h comma k, and then the minor axes is our vertical axes, and then our co-vertices will be h comma k plus b, and then it will be h comma k minus b. Same thing goes for the hot dog one. This one's going to be a vertical. Our vertices here are going to be at h comma a plus k, and then h comma negative a plus k. Our minor axis will be the horizontal. And then our co-vertices will be at, would be what? H plus b comma k, and h minus b comma k. Still to find c, you still have to use c squared equals a squared minus b squared. And this is the example of our horizontal ellipse, and then this is our vertical one. It's a lot easier once you start diving into problems. And then here is the general values that help us solve it. So, okay. The last one is our hyperbola. So the hyperbola again, our transaxle or type. This one's going to be a horizontal. And the vertical asymptotes will still be at y equals plus or minus b over a x. And then our vertices will be at, should be h plus a comma k and h minus a comma k. Our foci, which is denoted as c, it'll be h plus c comma k and h minus c comma k. Our co-vertices, it's not really, you don't really plot them all that often, but if we do, it's locations at h comma k plus b and h comma k minus b. Same thing goes for our vertical hyperbola. This one's at y equals plus or minus a over bx. Our vertices is now in the y coordinates, so it'll be h comma k plus a and h comma k minus a. Our foci will be at h comma k plus c and h comma k minus c. The vertices will be at h plus b comma k and h minus b comma k. Still the same thing. To find c, you can still, or any other values that are not given, we can go c squared equals a squared plus b squared. And then the horizontal ellipses look something kind of like this. And then the vertical ones are here. And then these are dictated by our values that we have up top. Okay. So let's do some examples. So it says graph the following conic sections and label the key parts. So here, by looking at it, I noticed that this is a circle. So with it being a circle, I need to look for the center point and the radius. I know the radius is 3 because r squared is 9, and then the center point is dictated by my h and k. So h is 2, and then my k is at negative 3. So I'm going to go find that. So I'm going to go 1, 2, and then 1, 2, 3. So I'll plot that there as my center point. Then I'm going to go 1, 2, 3 here, 1, 2, 3 here, 1, 2, 3 here, and then 1, 2, 3. And so all I gotta do now is just making the circle. Okay. For B, because of the subtraction in there and it being equal to 1, I'm thinking that this is a hyperbola. So the main things that I need to look for is my vertices, my foci, and let's look for the asymptotes. So I know from previous sections about hyperbolas, our a and b doesn't change. The only thing that changes is the x and y. So this here is my a squared, and this here is my b squared. So a is 3, and b is 4. To find c, I can go c squared equals 9 plus 16. So I got what? C squared equals 25. So C equals 5. Okay. Now, there's a shifting here. So my H is -2, and my Y is at 1. So that means my center point of this hyperbola is at -2, comma 1. So from here, I know that I can go up 4 units for my co-vertices, which is not that big a deal. But I need to go 3 units for my 1, 2, 3. These are the points of my vertices that are going to be on my hyperbola. 1, 2, 3. So it looks something kind of like this. And then the coordinates for the vertice here is at 1, comma 1. And the other one is at 1, 2, 3, 4, 5, -5, comma 1. My two foci, I have to go 1, 2, 3, 4, 5. My foci's here, and I got 1, 2, 3, 4, 5. Got another one here. So one is at 1, 2, 3, 3, comma 1, and the other one's at 1, 2, 3, 4, 5, 6, 7, -7, comma 1. And then my asymptotes are dictated by y equals plus or minus b over ax. So this would be y equals plus or minus 4 over 3x. So that one's the hyperbola. For C, I do believe that this looks like an ellipse. And so what I have to do first is divide everything out by 400, because I have to get that equal to 1. And so I'm going to have 25 divided by 400 is going to be that's 16. So I got what? X plus 3 quantity squared over 16 plus, I'm going to have y minus 1 quantity squared. That's going to give me what? 25. And this is going to equal 1. So the things that switch is my a and b. So this is going to be my a squared, and this is going to be my b squared. So from the looks of it, it looks like we're going to have a hot dog ellipse. So with a being 5, b equaling 4, c on the other hand, I can find that out by doing c squared equals 25 minus 16, and that's going to give me 3. So I need to find the vertice, the co-vertice, and the foci here. So my center point is going to be at -3 comma 1, so let's find that. 1, 2, 3, and 1. And so now I know that A is 5 and it's going to be a hot dog, so I'm going to move up and down 5 units. I'm going to go 1, 2, 3, 4, 5 here. 1, 2, 3, 4, 5 here. So this one's located at -3 comma, so this one's 6, and this one's at -3 comma 1, 2, 3, 4, 5. Co-vertices are dictated by B, so it's going to move 4 units. 1, 2, 3, 4. So this one's at 1 comma 1, and the other one's at 1, 2, 3, 4, and that's at 1, 2, 3, 4, 5, 6, 7, -7 comma 1. And the foci, well, I'll just connect this to make my ellipse here. And the last thing is the foci, and that's going to be, what, 3 units up, because it's always goes along with the major axis. So I got 1, 2, 3, and 1, 2, 3. And this becomes -3 comma 1, 2, 3, 4, and -3 comma -2. Okay. And the last one for this part of the section, yeah, I still got some time. So the last one here I'll do, this one's a parabola. And my x squared is the one that's a squared, so this one's going to be an up and down. Well, because it's positive, it's going to be an up. So center point, or point of my vertices, I'm sorry, is going to be at -2 comma -6. So I'm going to go 1, 2, and then 1, 2, 3, 4, 5, 6. So it's here. What I need to do is I need to find what P equals. So I know that 4P equals 8. So P is equaling 2. So that's going to help us find our focus and our directors. So the focus is, I know for a fact it's going to open upward like this, and it's going to be 2 units up, so it's 1, 2. So it's going to be at coordinates -2 comma -4, and then the directrix here is going to be 2 units off from the vertex, and that is at y equals -8. Okay, that's part 1. So come on back for part 2 in a little bit. I hope this helps. Until next time.